Hey folks, welcome to HVAC Talk with Huff. I am Huff. It's been a long while. I had to take a sabbatical a little while. I had surgery done on my back, and so I've been kind of out of the pocket for a while. And when I decided to get back into it, I was looking for some folks, and I had connected with Drew Tozer via social media with his Electrify Everything group on, I think, Facebook, if I remember correctly. And as I was reaching out to folks, I just really kind of wanted to kind of dig a little deeper into the HVAC world. There's a lot of people out here that are showing you how to, troubleshoot relays and do all those kind of things. I want to dig deeper into the science and also realize that the building science, there's a lot there that I haven't spent a lot of time studying, but I realize now just how important it is. And so I've been actually doing a lot of learning myself. And Drew wrote this book called Feel Good Homes. And he wrote this actually for homeowners who are prospective buyers of new HVAC systems. But be quite honest with you, there is a lot in here that an HVAC contractor and technician can glean from. And so Drew and I set a date that we could connect together. He was willing to do it, and I was so thankful. And so when I originally started talking to him, I'm like, I try to keep these videos at 30 or 40 minutes or so. And let's just say we went about an hour and a half, I think, or something like that, if I remember correctly. And just could have kept talking. Matter of fact, if I hadn't had another appointment that I needed to be off to connect to another meeting, we would have kept talking. Matter of fact, we're going to do a second round and discuss some more things. So I am going to just segue and just start the video of the interview I did with Drew. I hope that you get something out of it. If you like it, please like and subscribe. And be on the lookout for the next video coming. I got some other guests that I've already got scheduled, and I'm really excited about some of the folks that have been willing to come on to the YouTube channel to talk about all things HVAC, get into the science of HVAC as well as into management, understanding how we can grow better, understand how we can help our technicians. Grow in our industry and in our careers. And so I hope that you enjoy the content that we bring. And so without further ado, I hope you enjoy this interview with Drew Tozer. So we're here today with Drew Tozer. I'm excited. I'm excited about his book. I actually have, by the way, I have two copies. I have a paper copy so that I can highlight. I also bought it on Kindle just because I like having an electronic version. So if I want to refer to it later, and I go dig out and find the book because I got a whole bookshelf full of these books. My wife gets after me. She goes, "Why you got to buy everything in twos?" I'm like, it's just better. Twos are better than one. So Drew, I don't actually know a lot about you other than your book and just seeing you online and your online presence and Electrify Everything. So tell us a little bit about you and who you are and where you're at right now as far as in your business, and what you're doing.
Yeah, so my name is Drew Tozer. I run the front end of an HVAC company called Boundary Heat Pumps in Toronto, Canada. I got into this as an energy advisor, actually. So by trade, I'm an energy advisor, which I think in the States is the equivalent of a trader. So I was going into homes, doing energy assessments, doing the blower door test, the energy modeling, kind of creating roadmaps for homeowners to electrify their homes. And the problem I ran into was that I would finish that work and hand over a report to the homeowner. And then it was like, okay, good luck. Like, I hope you find a contractor or different contractors that agree with this whole plan and don't say the opposite of what I just said. And unfortunately, that was kind of where a lot of the homeowners ended up, would be getting the opposite advice from a contractor, and they would be stuck in the middle between two experts. So that was eventually where I took my step into partnering with a contractor so that we could actually do that whole project from start to finish, from consulting and concierge all the way through to actually doing. So there was a heat pump symposium a few weeks ago in Toronto, and I was joking because Travis, my business partner, was there. So I was joking with everybody that this was Travis. He's the one that actually does the work. I just like talking about the great work that he does. Yeah, so that's kind of how I got into HVAC, how I got into this. I'm here for climate reasons. So I'm here as part of Electrify Everything, that movement. Homes are a big part of the carbon emissions in Canada, in the US, in the world. And heat pumps are the only real path we have to sustainable heating. And so my goal is really to push, accelerate heat pump adoption just by showing owners and contractors the universal benefits that heat pumps can provide above and beyond the carbon savings. Because for every heat pump that we install, we get the carbon savings from those projects, whether the person did it for climate reasons or comfort or air quality or safety or whatever the reason is, we get the carbon savings all the same, which I think is a pretty magical thing that we take for granted. And I think that we should just lean into all the other benefits.
So it's funny that you say that because I got into a conversation with some folks actually at Rewire. But before I tell you what I said to them, how did you arrive at the climate issue that kind of drove you to that? What was your journey to that? Was it like during college or something, or what kind of got you there?
Yeah, it's always been something that's been important for me. So after university, I was in the solar industry. So I was actually doing all the rebate paperwork for engineering, procurement, construction, solar company, and then for a developer after that. After that, I was in the government running the rebate program. So I was actually on the other side of energy efficiency rebate programs for 5 years in Ontario. And a big part of it has been my sister and brother-in-law. Laura is a assistant professor at University of Toronto with a PhD, and she's teaching in this space. And Adam is running Shift, which is helping to convince kind of large funds to divest from fossil fuels. So a big part of this has just been kind of their influence on me and my career.
Well, it's funny you say that. So I'm going to say something. I want to kind of get your reaction to this, right? So I was asked, how, just in general, how do we reach contractors and want them to be a part of, what we're trying to do? So I have a consulting business as well, which I was already doing when kind of the Rewire thing floated by my way. And just for full disclosure, I'm actually a bivocational pastor. And we do a lot in our communities. We have a big clothing closet operation, and so we're all about, I'm all about trying to help them to disenfranchise and and folks who can't afford. And so when the opportunity came to actually help get high efficiency heat pumps in low income housing, I'm like, man, that's something I can get behind, right?
Yeah.
However, to be honest with you, so the question came up about this, and I kind of wanted to see I want to see your reaction a little bit. Is they're like, how do we get contractors? And this is what I said. Don't shoot me. Thankfully, we're a little bit away from each other. I'm like, don't lead off with the climate crisis. There's a lot of other benefits of heat pumps. Lead off with that. Because I find a lot of contractors, just like I live in a very rural area, right? And I live, even though I'm 70 miles outside of Washington, D.C., so I spent my contracting career before I went to work for OEMs, actually working out, of two of the richest counties in America, Loudoun County and Fairfax County, number 1, number 3 counties. Did a lot of geothermal heat pump stuff out in the horse country, Middle Oregon and all that. And so I was an early adopter of heat pump, but I live in an area where if we lead off with that, and some contractors I find are very conservative in the sense that they don't so much understand the climate issue as much as they can get behind the fact that high efficiency heat pumps are simply more efficient, right? When you start talking about COP and you show them a balance point worksheet, it starts to resonate, right? And so Have you found that up where you're at all? Any kind of pushback on the climate part, and then you focus more on the benefits of a heat pump because there's a lot of others benefits as well, or how does that hit you?
Yeah, it makes me think a few things. One is that for me, I think it's important to just highlight that climate change, carbon emission reduction, all of that isn't some small secondary benefit. It shouldn't take, like, as a topic, it shouldn't be a backseat to all the other stuff. So that's point number one. Point number two, though, is that we need to, for electrification to succeed, for heat pump adoption to increase, we need to pitch to people based on how they think, where they are, what their priorities are, all of that. And that's true for both homeowners. So that's why I talk about heat pumps more in terms of those other benefits than the carbon savings, because there are some people that will do these projects just for climate. Um, but that's always going to be like, that's a subset of the people. If we want everybody to do it, then we need the different messages for different people based on how they're actually going to make these decisions. Um, and for so the other part of this is that heat pumps are a path to sustainable heating because they use electricity, right? And we have the path to generate that electricity with energy. Whether that's happening or not depends on, like, it's a local issue. Depends on local grids and the generation mix in those areas. And so if you just talk about climate, if you just talk about carbon savings, you do run into problems in different areas, especially in the states where there's still a lot of coal-fired power plants. You kind of run into that wall of, well, if I switch it, like, yes, it's electricity, but it's just going to be created by burning coal to then run my heat pump. Like, is that even worth it? And long term, my answer is still yes, because the grids will all head towards renewable just because they're just cheaper, right? And they're faster to build and they're more flexible. Like, you get all that stuff. So we'll get there eventually for all the areas. But if we pitch those homeowners on just climate change, it's not going to work, because in those places, it's not an immediate benefit for carbon savings. Um, Whereas kind of the comfort angle, the comfort conversation, the comfort benefit from heat is more universal. It's not like a very regional factor like electricity generation.
Yeah, so and I love the way you kind of walk through that. To be quite honest with you, is I look at the benefit of both, right? So I'm one of those. If you compare me to the area, so I live in West Virginia, by the home of coal. Just so you mentioned coal fire,
Mm-hmm.
right? So I live, and know a lot of people. And matter of fact, my grandfather worked in a coal mine, so I get that. But I'm like, it's not sustainable, right?
Yep.
As you talked about, it's certainly not clean. It's certainly not great for the environment. But I use the multi-layered approach. There are people. So I used to get calls as a contractor where people literally wanted geothermal because they wanted to reduce their carbon footprint. They're like, I want to do as much as I can, and it was great. I loved working with those folks because they saw. Then when we started explaining the additional benefits, they were like sold, right? But it was like they were already sold on the fact that they wanted to reduce their carbon footprint, and that was great. But then there was others that wanted it literally just for the savings,
Yep.
right? Because once we put that loop in the ground, the loop had a 55-year guarantee, so they didn't have to worry about that loop ever again, right? Not to mention the geothermal heat pumps last a lot longer because they're not, exposed to such extreme conditions, and it was just a great thing. I was a big fan of geo. But also the inroads that's been made with inverter heat pumps now make you a harder sell, right? Because you can get nearly the same savings without all that extra cost, right? And so I really love the things that we're seeing now. And matter of fact, I have an inverter heat pump in my house, and I'm going to do an actual story about my house at some point, but and I absolutely love mine. But I'll have my resistance heat completely turned off, right? So when you do a load calculation, as you know, and so I'm not sure exactly what you guys do in Canada, right? So down here we have to be ACA manual J, and so we find that the manual J is very conservative. Like like I have found literally that I ran the load in my house with a few different programs and they all come up with slightly different numbers, but even the lowest one was off by almost 40%. And how I know that is I disconnected all resistance heat. I don't even have it active for defrost. Okay. And I'm still, our design temperature here is 15. And at 16 degrees, I was able to maintain 70 degrees with zero backup heat.
Yep.
Right. So,
Yep.
and that was 17,560 BTUs, by the way. I was still maintaining, right? So
Yep.
it's like, okay, and so, I try to, I tried to explain to some folks because they get so centered in on one point of this. I'm like, we need the full approach, as you're saying, right? We need to talk about climate change. We need to talk about the earth and sustaining it. But there's also great benefits of heat pumps, and different things are going to resonate with different people, right? So if you only use one of those approaches, I personally think that some people may not buy into it, but they can buy into the part of the savings, right? Well, I'll agree with the savings, and you know what? And if we get them a high efficiency heat pump and they benefit from the savings, our grid is still benefiting from it, right? So the net
Yeah.
result.
And the savings part too, it's another piece that I don't talk about too much because it's another very local factor. And it also changes over time. Like we're talking about equipment that should last 15 or years, right? And whether it's cheaper or more expensive than a gas furnace depends on those 15 years of energy costs that nobody knows. So
Right.
Even if it's more expensive or cheaper now, we don't know what it's going to be like 5 years from now. And like you and I are talking from very different places right now. And so especially when you're online, you're having these conversations on LinkedIn or Facebook, like people they're pitching in from all over these countries with very different views because they have different like on the ground conditions for these different factors. So that's just something to keep in mind on the savings part. It may be true. It may be true in one place and not true in another. It may be true now. It might not be true 5 years.
Yeah, I think that's a very valid point. I always say never give I never would give a certain savings amount. Like I'm like, you're not going to save this percentage. I never can
Yeah.
promise that. What I can promise is that, until you get below that balance point, a heat pump is always more efficient.
Yep.
Right. When you look at COP, I mean, it's just the physics works, right? But then I get into like there's also the comfort profile. What I like using a balance point worksheet and showing the different methods of heat. Like here's the smallest gas furnace you could do and the lowest modulation on that furnace because well, it's modulating. Okay, but look at how
Still
much
has a minimum.
yeah,
Yeah.
but look
Yeah.
how much you're still oversized,
Yeah.
right? And then I show them my variable speed heat pump and how close I can match my load for the majority of the entire season.
Yeah, that's right.
And so my comfort running at that lower volume, the comfort level in my house has never been better than it is now. And so funny thing is I live in the house I grew up in, right? I didn't always live here, obviously, but I moved out, got married, did all that. I ended up having to take care of my dad. He had dementia after my mom passed. And so when my dad passed, I ended up, buying my sister out and rehab the house. And now it has a much different heating system in it. So I've been in this house when it had oil. I also been in it when we finally got my dad to go heat pump, but he wouldn't let us size it correctly. He had to go too big, right? And so I've been in this house in different stages, and so like I know the comfort level now. So I love sharing the balance point worksheet of across my lifetime. Here's what it was like when I grew up because I knew what size furnace we had. Right
Yeah.
here it was with the wrong size heat pump, and here it is now. We went from a 65,000 BTU oil furnace now down to a 24,000 BTU variable speed heat pump that can maintain, right, all the way down to 16 degrees with no backup heat. And so it blows people's minds, right? So there is so many different ways to talk about this. And you do bring up some very valid points. If you get in too much into savings and then they don't see the savings, that becomes a problem as well. And as an OEM, I would run into that occasionally, where a contractor would promise a certain amount of savings, right? And they didn't see that.
Yep. And they won't know whether that happens until a year, like after the project is already done and installed, and they've moved on anyway.
Yeah, and so and it's always the equipment's problem, by the way. So I would always have to go out there because obviously this brand sucks now because they're not seeing because they were promised something way off, right? So I guess there's such a spectrum across all of this that is kind of interesting. So I love having these conversations, even with people that even have different point of views, different experience, because I think we all grow out of this, and that's kind of the whole idea is to talk and to grow in knowledge, right? And in understanding. And so I like some of those points that you brought up. And, I've been learning the building science part, because I've been so far removed from that. And so I'm so jealous of folks like you and others like Nate, that just like you guys understand these things. And especially on on the comfort side, because, I can tell you when I got into filtration, when it caused a static problem, when it caused a static pressure issue because somebody didn't size it right. That's when I got into filtration issues, right? It's like, well, you're using a filter that, has a static drop across it of 0.48 because you bought it at Home Depot, right? And so now your problem's causing the equipment problem, and that's why I'm involved, right? Yep. And so kind of getting into some of the IAQ stuff in your book, monitoring the PM 2.5, right? And the CO2 is like, so some of these things I'm like really starting to really dig into and want to do better, right? Because as a practitioner, I can teach a lot about the science of HVAC, but the home building science is like just it's new. And but the problem is that I know a lot of HVAC contractors, and they're a lot like me. All we've centered in is on how to heat and cool at home, and not
Box.
get just a box. So right, so okay, we do. I mean, so listen, in our world, if we got somebody that at least does a load calc on every job, we feel like we've gotten somewhere.
Oh yeah, yeah, and I mean, even circling back to your point about manual J versus the reality for your house, I think we are starting to have bigger contentious conversations about heat load calculations and the accuracy and manual J. And in Canada, there's F280 and our energy modeling software is 2000. And all of those, like I have no problem with the underlying math, the underlying formulas in manual J, in F280, in all of the modeled heat load calculations. My problem is that most HVAC is oversized. Like on the ground, most HVAC is oversized, and those are the sizing tools that we are using. And so obviously there's a disconnect between the tools that are running on those formulas or the inputs that we're adding to it. Any of those things, we're just not getting the other answer out the other end. And it is a problem with heat pumps versus furnaces, just like for your house where like you couldn't convince your dad to do it, probably because nobody is used to, like you're trying to pitch somebody to cut the size of their heating system in half. Right? We see them, they're kind of 2 to 4 times too big. So saying you actually need a furnace that's a quarter of the size, that's a big leap for homeowners and contractors, especially when they're used to a manual J or whatever heat load calculation that kind of can support whatever that original size is. And so I want to see more heat loads that are based on how the house actually performs. Because that's all we care about for heat load calculations and equipment sizing is how does that house perform in real world conditions, which is not what manual J or any modeled heat load calculation. It's guessing, it's modeling, it's all kind of theoretical for that.
Yeah, you're exactly right. So I was told by several different folks as I've done some research. It's like get aggressive when you're entering those load calculations. Like we've been taught to be conservative. Like the guy that I learned how to do load calculations from, the guy I learned how to design ductwork from. I'm talking just going back into the '90s. It's like we were always conservative because you didn't want to have that call where the heat didn't cover the load, right? And not realizing that the program was already conservative, the math was already conservative in itself. And so they're like, "Hey, Huff, when you do that load calculation,
margin on margin on margin."
Yeah, and it stacks up, right? And so I gosh, I look back and think, and this is like scary, but of how many oversized systems, Lord knows that I've put in, right? Myself.
Yeah.
And even though I was trying to do it right, but still not understanding the science, to be quite honest with you. But then we also get in the fact that we're doing load calculations without understanding the leakage of the house, right? So
Yeah.
the people aren't doing
Which
that.
is the biggest factor for heat loss in a house is the air leakage, and we just plunk a number in there, whatever default number we want to put.
Average, right?
Yeah.
We click average,
Mhm.
right? Or depending on the age of the house. Well, this is a really old house, so and so a buddy of mine just invested in a blower door test, and and I'm like, if I was going to go out and consult today on a house, if someone had an issue and they want to figure out, what's going on, I'm like, I've worked out a deal with him. It's like the first thing I would do would be let's do a blower door test to find out what our real envelope is,
Yep.
and plug that. And so we're doing the load with least real numbers that we know we aren't guessing at, because it does change. Because I've been messing around with just a load on my house by changing the leakage factor, and it just exponentially changes things. And it's like
Okay.
when we don't know that, and think about this, we're constantly every day contractors are going and doing load calculations without knowing that number at all.
Yep. And you can't possibly know the right size. I mean, at least in terms of manual J, like the models, you can't possibly get the right number at the other end accurately, consistently, without knowing the air leakage of that's why I always I'm partial toward I call performance based heat loads, which are either energy consumption, like gas usage, how much gas did the house actually use to heat it, or kind of for me the holy grail is the runtime data from the thermostat. How long did the furnace run when it was the design temperature, like when it was the actual target temperature outdoors for one of the coldest weeks of the year. How long did the furnace actually run for? If it ran for 30 minutes of the hour, it's 2 times too big. Like we want that to be 100% of the
100%.
time at design temperature.
Right. Yeah. And I don't think people understand that either, that a design temperature of that unit shouldn't shut off. We used to get calls, it'd be like 95 degrees outside, and our design temperature in this area was 92, and it'd be 95 out. And they're like, this thing is constantly running. I'm like, I know. It's
It's
great.
great. Yeah, we nailed it. Yeah, and that also means that it's dehumidifying for on the
Yeah.
AC side when you have the longer run.
Well,
That's especially on the AC side, that makes a big difference because of the latent load.
yeah, I had done an article for Gary McCready, HVAC Know It All, where we also think that this variable speed it makes it okay to oversize, right? We got variable speed heat pumps, and there is actually a table in the Manual J book in two different spots, and also in the Manual RH, which is kind of like our just residential. It's like a condensed version, and that table was pointed out to me years ago, and I've never forgotten it. And so when I pointed out to people, they're like, "I've never seen that before." I'm like, "It's in the book. Have you ever looked at the book? It's in the
Nobody
beginning.
reads the books.
And it's in the beginning pages. It's before all the boring stuff, right?
Yeah.
Where it shows a table where how sensible, right, as the outdoor temperature goes down, it shows the sensible on a cloudy and a sunny day. Just it's linear, right? Your sensible load is just trajectory just going down, but not the latent load. The latent load is more level and just barely, it just starts to tail off. Well, the problem is we got variable speed equipment that when they go into turn down, right, they don't have the same latent capacity they had at 100%, number one. Number two is we find in a lot of equipment now when we're in that turn down mode, that lower percentage, we're actually the sensible heat ratio goes up, not down.
Yeah.
And so now we really got an issue is where people oversize equipment thinking variable speed was the answer for dehum, and they made the problem worse.
Yeah, and the other side of that too, for heat pumps and just air conditioners, as we make them as like we are chasing efficiency. That's the thing that we are trying to maximize with heat pumps and air conditioner. But in the summer and cooling season, chasing efficiency, you're always choosing between latent or sensitive, right? Like to do dehumidification, you want as cold a coil as you
As you
can
can
get
get.
for as long as possible to actually cause condensation and remove water vapor from the air and lower humidity, right? But that's inefficient in terms of energy in versus energy out. So to to chase just efficiency and all those metrics, air ACs and heat pumps just on efficiency, you're always picking the kind of temperature, the sensible heat at the expense of dehumidification.
Yeah, and that causes comfort issues, right? And so we want high efficiency, but at the same time, we also want comfort. It is a balancing. I used to call it was a seesaw effect. Comfort and efficiency are opposing values at the end of the day when it comes to the summer, you know, months in humid areas. Now, if we're out in Arizona, it's a different story, right? If we're on the dry side of the continent, but in the summer months here in the humid area, I mean, efficiency and comfort are they're two different things, and we're always trying to balance between the two.
Yeah, I think that's true in like the thing that we're talking about now. I think if we were talking about building science, building envelope improvement, then those are the same side. Like if you are improving the building envelope and making the house more efficient, then you're doing both, and you're getting comfort and efficiency. Those tend to be bigger, more expensive projects. But certainly if we're talking about the latent versus sensible heat side of things, yeah, it's one or the other. And I think more importantly on the dehumidification and losing that piece, yes, the comfort part is important, but I think the bigger piece to that is the mold, right? The risk of having high humidity in a house for longer periods of time is a mold risk, and that's a much bigger issue, concern, expensive problem to solve if it happens, than just being uncomfortable.
Yeah, so there's a lot greater health risk involved. Absolutely. And I ran into a weird issue. This was probably about 5 years ago when I was still with an OEM, where the equipment was actually several years old at this point. And this was like, I want to say their second or third system they'd had in the house. They built this house in the 80s, lived there like ever since. They raised their children there. Like when they built the house, their kids were toddlers, and now their kids are all grown up and married and they're gone, right? And so there was one son that had come back to live with them for a while. He was kind of in between jobs, but they had some old issues, right? So, but when I talked to the contractor about the system they installed, it was actually a two-stage heat pump. He's like, "Well, Huff, we put back in there what was in there. I mean, same size." I'm like, "Okay, well, that's a
It was
problem."
the wrong size before, though.
Well, what if it was the wrong size before? But so
Yeah.
there was a weird issue that come up. It had never had this mold. That's what the homeowner saying. We'd never had this mold problem before. Mold problem was in pocket areas, right? You could see where there was no air movement in those areas. It was stagnant areas. That's problem number one. And so, okay, we probably don't have runtime. We definitely are oversized. But of course, we checked the box to make sure that the dehum rate and all
Box is
and
working.
sensible and latent was where it needed to be as far as the extended performance tables, right? Which is what an OEM would do. And we were looking deeper though, and you ever just have something hit you like weird, like you're like. So when we pulled up to this house, it was a hot day, like it was like I want to say it was like early August, and I had a guy with me because I knew I was leaving the company and I was training this guy to take over tech support for the company I was working for, the brand, and so we were together. And we literally had a laminated psychrometric chart with us, right? Because we like taking that in, we like plotting it out in front of everybody. That way we can, right? There's no hiding this stuff. This is not trickery, right? So we got this big 11 by 17 laminated psychrometric chart, and we're plotting this thing out. And of course, the contractor's a little, at this point, he doesn't know quite what to think because he's never done that. And it's weird how many contractors don't understand psychrometrics, but that's a side point. But anyway, it just hit me like something was weird. I didn't see the sun shining on one part of this house at all. And it's like I worked like our meeting was like at 11 a.m. By the time we get done checking out the equipment, wet bulb, dry bulb, all this stuff, and we're plotting this thing out, it's noon or a little after, because the first 20 minutes was this homeowner bending my ear really bad, and I'm like, at this point, it's a little bit after lunch, and there's no sunlight on this house, Drew, at all.
Turns out trees grow.
That's exactly what it was. I'm like, wait a second. Do you have any pictures of this house, like when your kids were little? They're like, yeah, when we first moved in, and they're like, all this sun shining on this house.
Mm-hmm.
And
And we
now,
love the amount of sun that we got there.
yeah, and but they planted all these trees,
Yeah.
right? There was some of the trees were little because the builder had planted strategic, Well, all these trees are now like 30 years mature, And I'm like, the load on this house is completely different
Yeah.
than when the house was built. And the contractor looked at me and was like, what do I do? I'm like, and so I turned them over to someone I know that did blower door, did loads, and that's kind of what they specialized in. I'm like, get this guy in here. I don't know how you're going to mitigate this between the homeowner. This is not an equipment problem, but if I can help you on price of equipment, if you got to change something or whatever, but you went in replacing what was there, and this is we tell people not to do that, but this is the first time it bit you, and I'm sorry, but this is the real problem here. And so I ended up stepping out and turning it over to someone who specialized. That would be someone like yourself, right? Who would go in and do the full deal. But that was the problem. And trees. Who would have thought that was going to be the issue, But I live in the woods, right? So my house doesn't see sunlight until 2 in the afternoon, And so when I was sizing my house, the shading is also another thing. Is people just kind of leave that alone. I'm like, man, I really tried to get aggressive on mine because I wanted to learn more about it. And so I worked with the guys at Amply who let me use theirs. Or like get aggressive, and they coached me up a little bit. So it's been interesting to learn all of this. So I go in now. That way because I'll talk about the science all day. Let's talk about your inspiration for the book, and let's talk about the book. Right? Again, it's Feel Good Homes. I'm on my second pass through on this book, and I'm still highlighting stuff. Now that I'm not on post-surgical, I'm learning more about this book again. And so tell me about the inspiration of the book to kind of start off with. Like what drove you to this, and how did you arrive at, like, I'm going to write this?
Yeah, it was, so I was, like I said, by trade, I'm an energy advisor. Was having these conversations with homeowners in their homes, doing the blower door test, and helping them solve specific problems that mattered to them. And I just found that there was just a pattern, like there was a similar arc that all the conversations, all the kind of the homeowner journey following. And because I want heat pumps to succeed, and I wish that I could go into every house and have a 2-hour conversation with every homeowner about their house and their problems and what's best for their goals and needs and budget. I can't. That's that's too many houses, too many homeowners, too many problems. And so the book is basically it's like a 2-hour expert consultation with me and everything that I would tell you if I was in your house and teaching you this stuff. It's meant to be conversational. It's pretty short. It's easy to understand. I wrote it for an average homeowner that doesn't care about this stuff, right? That doesn't care about HVAC. They don't want to learn everything about building science. They just want to solve a problem in their house. And so it's a 2-hour consultation with me, but it's on their time, at their pace. And I'm giving it away for free to homeowners, either physical copies if you're in Ontario, or just PDFs of the book if you're anywhere else. For that reason of I want to get this information out there. I want to help more homeowners and
Well, and I can't, when you say you're giving this away, I was like, I can't believe this. This book is very rich, and so. But here's the thing that kind of strikes me: you wrote it for the homeowner, like it's a a consult with you.
Yep.
I'm an HVAC guy, and IAQ is just not something that's taught very well, right? I've been learning a lot about that and talking to different folks, like talking to and interacting with people like Nate and Kevin Hart and folks like that. But I'm telling my HVAC buddies to get this thing, right? And so I kind of find it interesting that you wrote it like as a consult with you from a homeowner's perspective, but it's like HVAC guys that we need to stop. I think the whole HVAC world needs to stop for a second and back up a little bit and understand building science a little better, And it's hard to admit that. I was talking to Bill Spallman. I was like, man, I'm just now getting into building science. Can you believe that after 34 years and being considered, right? I've worked for OEMs and I've spoken at big conferences. I'm building science. I mean, I get it. I get I've run into problems where I realized that there was issues. Like I remember building a room over the garage once, kicking our butts, right? And I'm like, wait a second. The way they built the knee walls, and there wasn't a vapor barrier. They had vented soffits. I'm like, you got air pulling in here. We have no way to stop. I mean, so I kind of understood, like there's some common sense stuff that we should all get, right? Not to mention they decided to make that knee wall area a closet because there was a lot of storage area. So they literally put an interior.
They couldn't decide if it was inside or outside the house.
Yeah, they put an interior door, right? No vapor barrier on the back of the wall, vented soffit, right? Then we had one that was literally the master bathroom was over the garage and water froze in the toilet. And they were like, it's the HVAC guy's fault. Right. So
Is it though?
And I literally, what I finally did, even at the being threatened by the builder, I just grabbed the drywall saw and I just started cutting holes into the knee walls. And when air started hitting me, right, and you could put your hand up around that. I'm like, you've got an envelope issue, right? So, I mean, there's some common sense things that tells us that if you have holes to the outside, it's a problem. I mean, we get that part, but there's just so much more to it, and there's so much more ways. And you're right. If we can understand the building science and work on the envelope, then we can actually get efficiency and comfort in a much more sustainable way, and actually and actually achieve both. Right, you kind of with the way you said that. I don't remember exactly the words you used. I'm gonna go back and listen to this again. But the fact is, if you improve the envelope, right, and we make sure we get the air where we want to get it from, when we want it, and we filter it and we dehumidify it, right, then we can actually also reduce the latent load and then actually achieve more efficiency out of our heat pumps, even in these humid areas.
Yeah, and either high humidity. I'm in Canada, so we have a bigger problem with low humidity in the winter as well. Like we deal with sides, but humidity problems are largely an air leakage. Like we in Canada, we like putting whole house humidifiers. Like they just sit on the ductwork near the air handler, and they just add water into the air. They just humidify the air. But low humidity in the winter is just an air leakage problem. And yes, you can throw energy and water at that problem to bring it back up, but the real long-term like that for I do think like I agree with what I said earlier about those being both on the same side for envelope upgrades, but I think it's important to highlight that most homes can install a heat pump and either solve or at least improve, improve comfort problems in their homes with just HVAC solutions. I'm on in terms of the fabric first versus heat pumps debate. I'm firmly on the heat pump side, with the caveat of let's do the right thing for each house, right? And that's really the journey that the book goes on, is that we shouldn't put a heat pump in every house. Like we shouldn't just force a heat pump in every house. We shouldn't force homeowners to do building envelope upgrades on every house. Like every house is different, and the goals, needs, and budget of the homeowner and the house are different. And so we need to find solutions that kind of fit within that and will actually lead to projects and solve.
Yeah, and that becomes kind of very clear as you go through here, right? But you said, all right. So I'm gonna read a section if you're okay with that, right? It says the science is clear, though a house does not need to breathe, right? Allison Bales will be very happy with that.
Yeah, the book is right there. Does the house need to breathe?
I can see it. Yeah, I have it back here as well, right? it says it does not need to be drafty, right? It does not need to breathe. It does not need to be drafty. Building materials need to dry, and homeowners need fresh air. It seems like a small distinction, but it could be the difference between an old drafty house and a feel good home. The goal isn't to find all the holes, right? So to me, this spoke to me, and I'll tell you why. Is because sometimes like perfection can sometimes hinder us, right?
Yeah, be the enemy. The perfection can be the enemy of the good.
Of the good, yeah. And so it's not to find all the holes, it's to make the house good enough so that you can control the indoor conditions with the right size heat pump. That is so much wisdom in that right there. I mean, I highlighted it in case you can't see that. It's like, to me, that just kind of spoke to me. And it's like, it makes you stop and think, right? It's like, okay, we can't get perfection, but we can slow down, take a true look at what we have. And so you have the acronym Haven, but even in that acronym is broken down into three sections, right? The assessment part. And so what would be, again, most of my friends are HVAC guys. So without these guys having a blower door set up, when you come to assessment, what would be some um, um, suggestions or some advice that you would give a contractor when making an assessment when they first walk in to look at a house?
Yeah, just on kind of the passage you read, and just to give appropriate reference to that. Like, yes, that's a big Allison Bales is a big part of that. Nate Adams is a big part of that, and especially Joe Stebrick has an incredible article about airtight and ventilate right, and that whole article is about kind of trying to get to 3 ACH, 3 air changes per hour, which he just describes as good enough. Like, it's just stop the big holes, seal the big hole, and that's usually enough to get it to 3 ACH, and that's usually enough to start controlling the indoor environment with just. So just kind of shed out to all those much bigger, smarter people in the industry that I'm kind of just repurposing their idea about, let's just make it good enough on air tightness. Yeah, and then so for Haven and for the kind of the different steps for that, it was assess, shift, and plan were the three big steps, and a very important fourth step, which was implement. It's actually doing the work, because the best plan in the world will have no actual impact if you don't actually follow. But on the assess side for HVAC contractors, the biggest part of that for me is the heat load calculation, and an accurate heat load calculation based on the real world performance of that house in that area at the design temperature. And so Haven is the acronym that I made as sort of the framework, the 5 most important factors to consider for these projects. And H in Haven is heating. It doesn't work in the acronym, but like for anyone that's not in heating dominated climates, it's like it's cooling load as well. It's just figuring out the heating and cooling requirements of that house. So H is heating load. Like, it reminds me, so the story you told about the house with the big tree that now everything is suddenly wrong. The thing that HVAC contractors are used to doing is just going in and just doing an emergency replacement when HVAC dies and swapping it like for like. So ripping out the 2-ton AC and putting in a new 2-ton AC, ripping out a 60,000 BTU furnace and putting in a new 60,000 BTU furnace. And I'm sure at some point there was a heat load done for that house that showed that that was the right size, and it was probably oversized to begin with. But if you had looked at that house and did a heat load calculation, a cooling load calculation, based on either runtime or energy consumption, it's harder to do on the cooling side for conditioners. But if we do the kind of the flip of a house with a furnace in Toronto that had a big tree, and now suddenly they lost the big tree and they're getting a lot more sun or whatever, and it changes the heating load. If you do the heating load based on how much energy it used or the runtime of the equipment, suddenly you would be looking at how it performed last year with that equipment, and you would be much closer to the right answer, the right size. Like it would be based on how it performs with that new tree rather than just whatever the old. So that's the big part of assess is the heating load calculation. And if the heating load is low enough, then usually we can solve or blunt these problems with just HVAC. When the heating load is or cooling loads are too high, then it's a bigger conversation about what's wrong with the house and is there like what is the air leakage, which is the A in Haven, air leakage. What's the air leakage? What's the insulation like what's actually causing these problems? Like we need to dig deeper at that point.
Yeah, so in that air leakage part, again, I'm assuming, most of these contractors, and I'm not assuming, I've been dealing with contractors for years, just from the OEM side, that most of these folks do not have the methods, they're not in here going, they don't have blower door setup, stuff like that. But what I have found is like, when I find that a lot of people just will totally ignore holes. They'll totally ignore, right? They go into an attic that is so poorly insulated, and yet they replace the equipment like for like, right? Not only that, they'll put it on ductwork that where like the duct wrap is falling off.
Yeah.
It's back when they didn't seal, right?
You put a hole in the wall and you don't seal the hole in the wall.
Well, not only that. So I came from I'm like the last generation that grew up under the old school like duct guys and stuff. My dad was a duct guy. That's how I got an HVAC, right? I knew from my old man that I did not want to be a duct guy. I wanted to be a service guy. I wanted to work on the equipment because those guys had better vans. They had air conditioning in their vans. And I just didn't want to do sheet metal. I just like I didn't want to do it. But my dad was happy doing that. He was a craftsman. He loved it. But so growing up in that though, when we were doing slip and drive connections on ductwork, if you had to tape that connection, it's because you didn't do the slip and drive connection correctly. Like I remember my dad taking a screwdriver and a hammer and just making sure he tapped S slips to line them up with the drives to make sure they looked exactly straight across. And if you put a piece of pipe and crimped it and put it inside another piece of pipe and the crimp showed, then you had to use a piece of chrome tape around that crimp because you didn't do your job right. Right. So they wanted people to see their work. And so imagine that you had a system installed in the 80s with people that grew up like me doing this kind of thing where we didn't seal ductwork. And that now you're putting a high efficiency system on ductwork that didn't actually have the joint sealed. You didn't pay attention to it and you didn't address it. And the problem is sometimes a lot of this ductwork is accessible. It's in an attic that you can get to dang near every piece of that system. Why would you not seal all those connections and with mastic and then rewrap it, wrap over top of the wrap, right? Extra insulation is certainly not going to hurt. Now we got R4, and so it's amazing to me where people don't, the assessment, not just air leakage in the envelope, but just air leakage out of ductwork things. They just gloss completely over them. But it's like, we can, even without blower door tests, contractors can see, they can look, and there's some obvious things that will stick out if you're paying attention, right? For air leakage problems.
I like the bigger kind of the spirit of the law for assessment is trying to find and solve a problem in the house for the homeowner. The problem isn't the furnace is broken. The problem isn't the AC is broken. It's not like we treat HVAC as this binary system of it's either on or it's off. I either have heating or I don't have heating. That's the problem we're solving, right? And when that's the problem we're solving, it means that the service we're providing is very commoditized. So or like homeowners just pick an HVAC contractor based on the cheapest one because any contractor is going to go in and up the furnace with a new furnace, oversized furnace, and the heating's going to be back on. So they pick the cheapest. So a big part of assess is kind of separating yourself from that race to the bottom so that you can have bigger, more important conversations with homeowners where you're talking about air sealing, you're talking about that duct work, talking about the room at the top at the back of the house that is always too cold. Like you're trying to solve those other problems. But to do that, you have to, that has to be the goal. That has to be the conversation that you're having. And like the other side of this the other part of this for contractors, like I am here for climate reasons. I'm here for electrify everything. but the rate that we electrify everything largely depends on contractors. It depends on whether contractors buy into the work. I think it depends whether contractors buy into heat pumps being trustworthy and reliable and they won't cause problems. It requires contractors to not oversize equipment because they're worried about the callbacks. Like they're not just thinking, oh, if it's too big, then it's not too small, and that's good enough for these projects. And like on the building envelope conversation about improving air sealing, doing deep energy retrofits, net zero homes, all of that. It's like those conversations start, I think, with HVAC contractors, because HVAC contractors are the ones that get the call from the homeowner when the HVAC breaks and when they are suddenly thinking about their house, right? They're not calling an insulation contractor any other time, right? They're calling an HVAC contractor. So if we can get HVAC contractors to think about these bigger picture problems and solutions, I think it'll, like, downstream from that is more energy efficiency projects, more deep energy retrofits. All of that other work starts with these conversations that HVAC contractors.
Yeah, and it's a difficult one. And when they don't understand and they don't buy in, it makes it difficult. I mean, I had to convince my wife that putting in a smaller heat pump in our home was going to make us more comfortable.
Yeah.
Now, my own wife,
Bigger's better, right?
well, yeah. So when you tell somebody, well, you got a 3 ton now, well, can I get a 10? Like,
Yeah.
no, we're actually going
Yeah.
smaller, right? So it's a difficult conversation to have, especially if they don't understand. And it's the easy sell when you just sell them what they already have, right? So
Yeah.
that the mindset has to change. And it took me a while to get there, to be quite honest with you. And so, but when I kept seeing problem after problem, knowing it was a load problem, knowing that equipment was oversized, that's what started to convince me and started to take me down this road. And so it's been a long journey for me to finally get there. And it was well before I got to Rewire and working with those folks. But at the same time, I was already there and really starting to do research on, how to do load calculations better or to understand the envelope, because I was just tired of going in. But and the thing is, you say that most of the time a system did have at least have a load calculation. Sometimes I would even question that, to be quite honest with you, right? It was an old home that had no air conditioning originally, and then they got somebody on a side Bubba's out there doing the finger method. Well, two
Yeah.
fingers, 2 ton, 3 ton.
What's the square footage?
Right.
Yeah.
So I was in a class with Hank Rukowski, one of the lead guys with the Manual J. I was they used to have this epic class. I don't know if they still do it or not. But he was talking about, and he showed the difference between an old 10 Sierra piston coil, big compressor, small coil application versus small compressor, big coil, right? High efficiency, and the runtime difference it takes to get to full latent condition, and what the full latent condition change is.
Yep.
At the same CFM now, right? So if you're talking about right at 400 CFM per ton, the piston got to full latent condition much quicker, and it was actually a lower sensible heat ratio than the more high efficiency coils with TXVs, right? So, I remember him saying, "Just give me an old 10-0 system any day." I'm like, "No, we can actually get new equipment to run like that if we understand what we're doing."
Yeah.
Right. And so setting them up correctly. And so I've been trying to explain to people, you can understand, you can affect, if you do things correctly, you can affect the sensible heat ratio, and you can affect it when you want and when you need it. Right. It doesn't have to be 400 CFM a ton, and so we can look at that. But it's like, it takes a lot in some areas to convince someone to go to a smaller system. It's just it's a difficult sell.
Yeah,
Right.
and just I feel like it's worth taking a step back and explaining why bigger isn't better, why smaller leads to better. And the big thing for, like, for ducted systems, which is mainly what book talks about, it's mainly what I put, because it's the type of system that I see the most.
Right.
When you have an oversized furnace, like a furnace that is 4 times too big, it's never the right size for the house. So if it is running 4 times too big, means when it's the design temperature, it's running for 15 minutes of that hour. It's running for a quarter. And when that happens, all the furnace is trying to do is make the thermostat happy. It's trying to satisfy the thermostat. And the thermostat's always kind of in the middle of the house on the first floor, living room, in a very central location. And so the thermostat gets cold, it calls for heat. The too big furnace turns on, dumps heat into the house through the ductwork until the thermostat reaches its temperature. And then it turns the furnace off, right? But that means that all of the ductwork, like you can picture the heat going through that ductwork, right? And it's a pretty short run from the furnace to the thermostat. But the far away run, that ductwork is the heat's running all the way through that ductwork, and it's almost making it to the top floor at the back of the house. And then the thermostat's happy, stops calling for heat. The heat never makes it to that top floor at the back of the house, and it keeps doing that. It's just short cycling where it's not running for long enough to get all the heat. Like if we were talking about perfect scenarios, yeah, all the ductwork should be sized right so that all the heat gets distributed to where it needs to be. But in reality, that's not what existing houses are like. And so smaller is better because the longer run times, like if we get that 100% runtime, it means that, yeah, the heat is actually making it to the back floor at the top of the house. It's making it to all the rooms where it's supposed to be. That means, one, it's getting heating and cooling to those spaces. It also means that you're actually mixing all of that air. You're not going to get the big temperature differences between the floors because you're having air actually make it to all those spaces. And then on the air quality part, it means that you're actually filtering all of that air more often because the system's actually running. Like filters do nothing unless air is going through them, right? It can only filter, those mechanical filters are only filtering air that passes through.
Well, exactly. And so kind of what I was going to get to though, when I was talking about is, so, when I explained, when I was listening to, Hank talk about that, and I'm like, no, we can make new equipment work. You got to understand it better. But I was also getting to the point. So there's been times where I've like literal situations where I always call him Bubba, right? Because I live in West Virginia and I know some people named Bubba. Bubba sized the house wrong. But he also used like this base model builder system, 10 seer with a PSC motor, air handler. And he undersized the ductwork because he didn't know how to do that either.
Yep.
Well, we have a piston fed coil with undersized ductwork, which means the air slowed down, you got better dehump, and you elongated the runtime.
And the lower efficiency also meant that you weren't just chasing efficiency over dehumidification. Right.
Yeah, and so it worked by accident is what I try to tell people. It worked by accident. But the problem is
you failed successfully.
You failed successfully. But the problem is now you go back in and you go in with a high efficiency system. And when you're talking to the homeowner, you're like, yeah, that one bedroom never really did it. Well, we're going to put a variable speed blower in here and it's going to help overcome this ductworok problem. Well, variable speed is not a fix for bad ductwork. We all know that.
Especially when it's small
ductwork. Right?
It's the opposite of a fix for that.
I remember when the Carrier Infinity come out and it would measure static and like they had to increase the static. And it used to be, I think the static maximum was 1 inch. They had to increase it to like 1.5 because
otherwise they would just fail.
The system wouldn't run. It would say, I can't run, right? It would go off on air fault. And so that's how bad ductwork was. Well, the problem is that you got this variable speed blower that's trying to overcome this bad ductwork. And now you have a system that doesn't have the same sensible heat ratio as well. And so now we're short cycling because that's what oversized equipment does. It short cycles. That's what you were talking about, right? And so when you already understand that 99% of the time, right, in theory, if you were to size the system exactly to the load, 99% of the time you're already oversized. Mm-hmm. And so oversized
shoulder seasons, you're 10 times too big.
Yeah, right. So that design temperature is that 1% column, right? You're at that 1%. You're at that temperature at one or above that temperature 1% of the entire cooling season, which means 99% of the time you're below that.
88 hours a year.
Yeah. And so it's like when you kind of start to try to explain that, people start to see that, you're like, wait a second, this oversizing issue. I'm oversizing because I don't want the callback, but the problem is I'm getting callbacks now because I don't understand oversizing. Yeah. Right now I'm short cycling. I'm not, and then people would complain. And so I would ask what the complaint was. I said, because there's two kind of complaints. I set the thermostat to 75 and it doesn't get there. All right. That's usually a sensible issue or just a sizing issue in general. Or I set it to 75. It says 75, but it don't feel 75.
Yeah, I'm uncomfortable still.
I'm uncomfortable.
I don't like
right?
that number.
Yeah, that's a bad juju right there. I said, listen, I set it to 75 and I ain't getting there. I'd rather have that problem than I set it to 75. It says 75, and it don't feel 75. And then I drop it to 72. It reaches 72, and it still don't feel like 72. That's the bigger problem, right? And so those were the issues. I would go out and I'm like, I know what the issue is, but I couldn't address it, right?
Yep.
And so, the assessment part of this just really kind of hit me, doing the load, but also looking at the overall assessment. To me, I understood the spirit of what you were doing here and with the assessment, like the air leakage. But to me, I'm looking at air leakage not only from an envelope, but also from a duct perspective, right? To put a high efficiency system on a duct system that's going to leak, for every 1% of air loss, right, you get capacity loss, especially if it's an unconditioned space, right? So, I don't know about what you guys have up there, but we have a lot of systems in the attics here.
We don't. We have basements.
Yeah.
Yeah, and we never have duct work outside of the building. Like, no place should, but I do.
No.
I consider myself lucky that I'm in an area where that's just never.
So it's funny. My wife and I are designing our retirement place. When I say we're designing, we're in concept stage, right? We know that we got about 5 years before we're going to build this place. But we're going to do a barn dominium just because I want a big shop. I want a place to put our motorhome in, right? I want to put a car lift so I can change my own oil. I like doing that kind of stuff. But we want to have our living space, right? And so I'm actually going to do ductless, but in the sense that I'm going to have a big open area concept with my kitchen, dining room, living room is going to be a big open concept, probably ceiling cassette. But I told her for the bedrooms, right, because there's no head small enough, I'm going to use a ducted, low static, but it's going to be below a false ceiling. I don't want any ductwork in unconditioned space.
Yep.
So I'm putting a false ceiling in, right? So it'll be tall ceiling out in the big area, but the bedrooms will have a drop ceiling where it'll be conditioned space still. So I can put my ductwork conditioned space. I was like, I have learned this from all these years at this point. It's like ductwork doesn't, if you can keep it out of unconditioned space, it's just better, right? So I'm telling her about this false ceiling and how I'm going to drop the ceiling. Well, how far are you going to drop it? I'm arguing with her right now, but we're in concept phase, but we're going to get there.
We made it like we whatever height we want the ceiling to be, it will be that height inside.
I will jack the outer ceiling up higher, to get whatever ceiling height inside you need. But there's going to be a false ceiling in there.
Yeah. You're going to forget about it anyway, so
you're not going to know.
I shouldn't have told you about it.
Yeah, probably right. And so I look at that assessment kind of with that, but then you get into value mindset, right? And I think that's kind of an important part of understanding how to get the best value, right? How to get the best for that home, right? Because not every system is going to work for every home, right? So talk about that a little bit.
Yeah. So V in Haven is value mindset. It is about, like, when we were talking about emergency replacements and treating HVAC as a binary on-off system, value mindset is thinking about, like, the book is for homeowners, but for contractors too, thinking about what problems we're trying to solve and the value of those solutions, right? So the reason that HVAC is cheap and there's such a downward pressure on it is because it's a race to the bottom, and every contractor, all the equipment's all the same, so homeowners just pick the cheap. If you go in and if you are thinking about solving it, then suddenly it's not a race to the bottom. It's, well, what's the benefit for you to have a comfortable space, right? Not just a comfortable room, but like for my house, there's a third floor, like it was an attic converted into a living space. Knee walls, like you were talking about, where it's leaky and too hot in the summer and too cold in the winter. And that's like a third of the house, a quarter of the house per square footage. And it was unusable for 3/4 of the year. Like, you could use it for some shoulder seasons when you didn't mind the outdoor temperature, because that was going to be the same as the indoor temperature. And the value mindset is thinking about, well, what's the value for me suddenly having 30% extra square footage in my house by just kind of taking back that space that I can now use all year round. Like, as homeowners are happy to think about and plan and build additions on the back of their house when there's all this square footage of uncomfortable rooms that they just can't use for large parts of the year. So the value is, like, I think in the book it says something like, if you plan for if you plan to minimize the input, which is the price, don't expect a good output. Plan for, if you want the cheapest price, you're going to get the cheapest job, and it's not going to solve anything. Just, it's that mindset of thinking about the home and the solutions that we're actually trying to target, so that we can actually pick and install equipment or projects that are likely to get us there.
All right, so I equate this to tools. I try to tell technicians tools, right? When you got to look at value, you can't just look at cheapest price. That's not value, right? Because if you got to buy that tool twice because the first one you bought was this knockoff and it broke, and then you had to buy one again, and then you end up buying a cheap one. I mean, I've seen guys buy 2 or 3 cheap ones before they finally spend the money to buy the right one, right?
Yeah, or if it's harder to use, so it takes you twice as long to do that job with that tool, rather
right?
than the expensive one.
Right. So value is not just cost of the job. Value is getting the most out of and getting to the right, the right outcome.
Yeah.
Right. Exactly. And unfortunately, I got to be done by 11:45, and I really didn't expect that. You just been so easy to talk to, and I apologize. I know I'm going off script. I'm learning. I just know a lot of heat and air conditioning contractors, I think, that would just glean from your knowledge and your experience in this realm. And so I when we get into again, part of the environmental control, right, and necessary infrastructure, just kind of, you just want to touch on that just real quick. That's part of I know that's part of the planning, but that's an important piece.
Yeah, environmental control is basically picking the equipment that's likely to solve those problems, or picking if there's a bigger project, picking those other measures, those other upgrades
that need to happen,
so that you can control the indoor environment, which is the whole goal.
Right.
Which includes indoor air quality is a big part of that. So filtration are all in there, and the right sized equipment. So all of that is the environmental control. And necessary infrastructure is just the idea that our house, I always say our house is a system of systems. And so a house includes plumbing, but it also includes ductwork and all the electrical infrastructure that's already in the house. That's all very expensive stuff to upgrade or rip out and replace. Those are bigger, invasive projects when you're talking about ductwork. And so necessary infrastructure is just picking HVAC in particular, picking a heat pump that fits within the existing infrastructure. Ductwork, that means not putting in that oversized heat pump that's going to cause high static pressure, high duct pressure, that's going to burn out the fan. Like, there are limiting factors for electrical and ductwork that are very important to take into consideration. And for the ductwork, maybe it means that you do a hybrid system with a gas furnace backup, so that the heat pump can be the right size, so that you don't cause the ductwork problem. Like, I would always rather have a hybrid system that the home is happy with than a fully electric system that has some extra carbon savings, but the fan's going to burn out. The homeowner's going to be unhappy. It's going to be noisy because the ducts are too small. All of that. So the goal here is always happy homeowners, because that's how we make heat.
Yeah, and I love that approach because my first heat pump was actually a hybrid, but I'll tell you why. I just got married, had a baby, bought our first house, had an oil furnace, and they would only deliver like 250 gallon or 200 gallon minimum, or whatever it was. I remember it being like $600-700 that I didn't have at one time. Now, I knew I could go buy some number 2 heating oil, and just dump 5 gallons in at a time. But what happened was, I did a job in McLean, Virginia, and we were tearing out a heat pump system because they were putting an addition on the house, and we were increasing the size of the system. So I asked the homeowner, I'm like, what do you want to keep this system? I mean, it was completely running. It was a Train XL10. I'll never forget it. I'm like, what would you like to do with this? And they're like, nah, just get rid of it. We don't want. I took that thing, I put it on my truck, I took it straight home.
Yeah, it's like being a teenager getting your first car that you fixed up.
Yeah, and so I took that thing straight home, and I'm installing this, I'm talking it's winter. Like at this point, it was like I remember being like near Christmas, and we were like, man, we got to buy oil. Plus, we wanted to get Christmas for the kid. It's just like I mean, I was married and broke, right? So, and I'm like, I'm putting this system in, and she's like, what are you doing? I'm like, man, I'm putting this heat pump in. We're going to do a heat pump with oil backup. I've heard of this. Right. And she's like, heat pumps, those things never heat, right? So, and everybody around, all my family, like, heat pumps are terrible. And I go, look. So I rigged up this outdoor air thermostat, this outdoor air, it was outdoor air thermostat to keep your electric heat off. I don't know if you remember those old rigs that that people used to sell, right? So you would run your electric heat through an outdoor thermostat, to hold the electric heat off below certain temperatures. So I used that as my switchover, right? And I dialed that thing way back, and I dialed it like way, way back. And I'm like, I'm going to see how well this heat pump heats. Now I had a little 1,200 square foot rancher, 2-ton heat pump, and my wife was blown away that even in the coldest of January, we were still not using. I think I used less than 15 gallons the rest of the entire winter.
Can still get heat from cold air.
And she's like, I say, quit filling the register. Don't worry about what the register temperature is.
Yeah, the house is comfortable.
Is the house comfortable? What's the thermostat say, right? And so that I was sold at that point, but nobody around me was. So that was my introduction to heat pumps. Was I needed savings, right? And I needed help. And I knew, because I had been reading, right? Because I knew these heat pumps, that they worked, and that they weren't the old original ones from Carrier in the 80s that everybody had a problem with, right? So that's how I ended up going into the heat pump world myself. And so the fact that you see dual fuel as that option, because some people don't. And I'm like, sometimes, when you look at the temperature rise on the gas furnace, it doesn't need the same amount of CFM as that heat pump's going to need. And sometimes that is the answer, right? So looking at the infrastructure and saying what, for the value, if we can't tear all this ductwork out and do this differently, then we have to work with what's here. So I think that's very wise. But the environmental control, that's a part that also a lot of people are missing. I know IAQ is becoming a bigger issue that people are talking about, but here's the thing that I see that I have found in the field is like nobody talked about it, and then didn't realize the homeowner had like allergies or whatever. Nobody said anything. They sold that job with that 1-inch filter slot or that filter grill, and then the homeowner goes to Home Depot and buys, MERV 13. That's basically a brick wall that they put in a filter slot that lets no air through, right? How does it keep air clean? It doesn't let it go through. That's how it keeps it clean, right? You have to keep a pig clean.
Just put a piece of plywood in there.
It'll work just as good, right?
Yeah.
I literally we had a guy complaining about heat pump going off on head pressure, and we went out there, and I have a picture of that filter to this day, and I'd be happy to send it to you, because it was a 3.5-ton system, and the filter literally said 1390 CFM on this filter, right? It was like a 20 by 20, if I remember correctly. The pressure drop clean 0.48. And we had a total external static pressure of 0.99 when we measured it before we took the filter out. And I'm like, look at this static pressure. That's why you're going off on head pressure and heat, And so, they want a high efficiency filter. Then why didn't you sell them one? Why didn't you have that conversation? Right. So this environmental part is something that I think a lot of contractors are missing the point on, because people have concerns about it, but if you don't have that conversation about, what they're looking at for filtration. And honestly, we should be looking at it for them anyway. We should be already thinking ahead. We shouldn't be happy if they're happy with a 1-inch fiberglass. To me, that's just, I'm going to be talking about filtration even if they don't have concern about it. I think that we ought to be talking about it and doing it right.
Yeah, it also changes what your standard project looks like. So like we are joking about 1-inch MERV 13 filters. Like contractors and homeowners have this idea for that filter, that it is there to protect. That's how we treat filters, how we treat furnace filters. There to stop dust from getting into the fan and the coil. But it doesn't need to, right? And the reason that switching from a dust catcher 1-inch to a MERV 13 1-inch, there is a big pressure drop pressure, air resistance difference between those two. But the solution isn't stick with the dust catcher. It is you need more surface area of
Surface area.
filter. So
Correct.
that means both in dimension. So rather than an 8 by 20 or whatever return air duct with a filter in it, it's go 20 by 20, 24 by 24, like get that surface area. And then it's the thickness of it. Because a 1-inch filter has a lot less surface area than a 4-inch one that's going.
Right.
So that's the solution there. And I always tell homeowners that there for filtration for particles, there's two options for either you install a mechanical system to filter out those particles, or your lungs will act as the filter for those particles. Like those are the two outcomes for airborne particulates.
I've never heard it that way, but I'm going to use that and act like I come up with it. That's good, right? Your lungs become the filter. Well, yeah. So when we start talking about, I started, having that conversation with contractor about the pressure drop across the filter. But obviously, these people want good filtration, so you have to be smart about it and understand that we all want good filtration, right? But to be able to do that, you've got to be able to work within the pressure drop of the duct system you have. And how are you going to do that? Blow that filter up, right?
Bigger return air drop, bigger filter, thicker filter.
Thicker filter. And so I show them the difference. Here's a MERV 13, right? 20 by 25, 4-inch. Now look at the pressure drop across this filter. Right. But then, what another thing I find interesting is they'll take a gas furnace and cut the side of a gas furnace and they'll put a 20 by 25 filter against it. But the problem is the hole in the furnace is only 14 inches tall. So you got this much filter that ain't got nothing going across.
Or you go the opposite way where the hole is too big and then all the air just goes around the filter anyway. And that solves the pressure, the duct pressure problem, but doesn't filter anything.
Yeah, you're exactly right. And so I loved that you geared this for homeowners, but I'm telling contractors, take a look at this thing, right? Because we really need to start getting contractors to look at the whole, right? Look at the system holistically, look at the home holistically, realize that we're not there just to put heat and cooling in a house. We're there to make the house, right, to condition the space, right? We're there to make the house comfortable and safe to breathe. Right, all those things are important. And I remember I really got into filtration when my mother was really sick and she had a lung problem, and she was down to about 40% of her lung, and started looking, really into that part because my dad, he didn't really want to talk about that. He's got a weird setup that he had in the way the heat and air conditioning system is positioned in a home. I'm like, we got to do something better than this, and really start looking at it, and your lungs become the filter. And so that's a great line. So I want to end with this, and I hope this went okay with you. I know we went all around the spectrum, and I learned a lot. And I think some contractors that I know that kind of check this out are really, I think that hopefully at least it makes them want to go learn more, right, and to dig deeper into this. But you said contracting's hard. I saw that online. You're like, so we got about 10 minutes left. Tell me that. I want to hear what's behind that post that you had there about contracting's really hard.
Yeah, this actually started just as I live about an hour outside of Toronto. I do a lot of driving in and out of Toronto, and there's the rush hour, and you're always stuck. And there was this day where there was an on-ramp, right, of cars joining into the highway. I was already waiting on the highway, and then you see cars pull out from behind you onto the on-ramp and then zip up to the front and cut in. And before, I would always just it's infuriating. I would be so angry at those people, and like road rage is a real thing. And there was a day where that happened where I felt what I now describe as kind of radical empathy for that driver. And it was like either they are having a real emergency and they need to get to the hospital or home or wherever as quickly as possible, in which case, great, yeah, they should absolutely go ahead of me and that's fine. Or they are just feeling such road rage and impatience and like they're just they are like, I feel bad about the way that they are feeling that caused them to make that choice to cut off all these people. And that too is like, well, I feel bad for the way that they are feeling, and yeah, just having empathy for the way, like the situation that other people are. And so I started thinking about that more in other areas. And for contractors, it came up. I've always been on the other side. Like I'm a converted contractor. I'm recently over on this side of the fence. And when you're on the other side, when you're an energy advisor, or you're on the other side of rebate programs, you see the bad practices. You see the stuff that should be better. You see the bad results. You see the race to the bottom. You see all that stuff, and you want to just say you should just be better. Like, just do a better job. Don't cut corners, like all of that stuff. But then when you're on the other side, I have a lot more empathy now for how hard it is being a contractor, and just the fact that most contractors are running around just trying to win the next job, just trying to just make enough money to support themselves and their families. They're all small businesses where it's an owner operator that's wearing all these different hats. That's just they're trying to make enough money to keep paying their employees so that they can support their families. So there's just the point of that post was mostly to, like, I give contractors a hard time. Like, a lot of my posts are still that old style of this needs to be better, and I still believe all of that. But I just realized that I hadn't talked about the reality on the ground of what it's like as one contractor. It's very different than when we're talking about the HVAC industry. And it's just so much more clear why the decisions get made, why everything's cheap, why everything's fast, why everyone's just trying to win the next job and make a living. It's so much more clear once you're on the other side. So I just wanted to spread that message of, like, people are just trying to do their best. And it is hard as a contractor to stop doing what you're doing and think about this other stuff. Think about the bigger picture. Think about climate change. Think about carbon emissions reduction. Think about other business models. Like, it's so hard. It's a pretty privileged place to be able to have the time and space to think about that work when they're just trying to win another job. And the only way they do that is to be the cheapest, in that quote.
Yeah, it's funny. I didn't know I didn't know that was kind of the motivation behind that. 'Cause I was kind of wondering, like, kind of how, what, the spirit. You can only glean so much out of
Yep.
out of written word, right? You can't get tone, things like that. I like the story about the on ramp too, though. How I just, you sometimes you think about things differently.
And now if anybody else is in the car and they get mad at somebody zipping by, I'm
Yeah,
just like, oh, they're having an emergency. That's fine. Like, they're doing what they have to do.
yeah,
It doesn't affect my time to drive home at all.
right,
I
yeah.
hope they get where they need to go.
Yeah, it's a much different approach, right? But I had a really weird moment where, having had spinal issues for a long time and was on some really heavy meds, and then I went off of them because I just I just felt like, man, this is affecting my brain. But the process of going off of them, like, gave me this empathy for folks who struggle with, like,
Yep.
opioid issues, right? Because I never realized how painful of a process that was, right? And
But when you
so,
haven't gone through, you're like, well, why don't you just stop taking the pills?
yeah, it's just no big deal, right? And so, yeah. So sometimes it takes something like that to kind of make us see. But the fact is, I'm just going to be honest. So I worked for what was considered a really good contractor, and I can promise you, we were not out there trying to do it wrong.
Yep.
But I look back and I see some of the things that we did and how we were doing it, and now I know that there's a better way. And so I know that there's a lot of contractors that are out here not trying to do it wrong. That's not their approach. They're not trying to screw it
They
up. But
don't want to cut corners and do a
they
bad job
no,
and cause mold problems.
but they know they got to make payroll this week. They're supporting 10 guys, right? Because most HVAC companies aren't that large, right? There are some really large ones, but small and local, right? And so they're trying to make a living. The other part is not understanding the science to be able to help the end user understand why this change. It's easier to sell what was already there
Yep.
than to try to get this change. And so moving this industry is not an easy thing. It's a large ship. to turn around. But I appreciate people like you who are staying at it, right? And making, I mean, you attracted my attention through your post. That's how I found you, right? And then it was funny. So then I'd already like been working on reading Nate's book, and then I saw yours, and I've talked to Nate actually on the phone once, but also interacted online. And you guys both inspire me. I got to talk to Allison Bales down at the HVAC symposium this past year, and so you guys inspire me to want to be to do HVAC better. And so then my work at Rewiring America was the fact that their motto is they're obsessed with the homeowner and getting right electrification for climate purposes, high efficiency heat pumps into homes for people who can't afford them, but also making sure the house is heat pump ready. Right there, it's not about putting heat pumps in houses that aren't going to work. Right, I want to make sure we make that clear. But to me, it's not finished until a contractor has installed it completely correctly, commissioned it completely correctly, and that's my portion of the role of making sure that happens. But it's really changing my outlook, right? And so I appreciate folks like you who put the effort into. Again, I know you. I will keep coming back to this. I know you wrote this for homeowners, but I've benefited from this book, and I've been doing HVAC for 34 years. So I appreciate you, and I appreciate
and
what you're
I
doing.
think the fact that the fact that it is easy to understand that it's meant for people that don't care or don't know anything about building science. Like there are no prerequisites that you need to read for this book. I think that is a benefit to contractors too on the building science side, where it's kind of just enough to kind of it's everything you need to know to start a building science journey. And yeah, you can dig deeper, and that rabbit hole just keeps going.
Right.
But it's the surface level.
Well, I like how you laid out the process, because then you can dig deeper into each of those areas, right? And you can get better, right? And so, like I said, I was already reading these other books that are some of them are some of these are very deep into the science, and I'm like, okay, I
It's like
think
a
I
science textbook.
yeah, and so for this, it gave me a framework to then go back and I read those books differently. I mean, I know that sounds weird, but that's just the way my mind works. But to me, I greatly benefited from it. I bought two versions, right? I want to support you. I just assume people go out and buy it to help if it helps you keep doing what you're doing. But I do deeply appreciate it. I hope you've enjoyed the conversation. I really have. I've benefited from it. And I really think that folks, this is the direction we need to be going, right? We need to understand that we are stewards of the earth. We need to take better care of it. We need to sustain, right? So there's a lot of people. I told them don't lead off with that to some contractors, because I know just some of the people that I deal with. Not there. I'm not sure I believe in that. Okay, but there's some other reasons here, right? Heat pumps have a lot of other value.
If they can just skip the climate change chapter in the book.
But I don't think they should, though, right? Because yes, if we want to, we want to get them there, though, because I believe, and I'm very, people know me, I'm very open. Even you don't have to believe the way I believe, and you don't have to be a religious person, but I do believe that we are stewards of the earth, and I do believe that we need to take the best care of it. And I want my grandkids to be able to breathe. Right. And so to me, they're like, I can't believe you buy into that. I get called a tree hugger and some other things, and I don't care. But I think we need to do our best, and I just don't think we're getting our best done in a lot of cases, right? But I don't think it's because people don't want to in some cases. But we need to do better in education, and so to me, this is an education piece.
Yeah, and like that post was about radical empathy for contractors, but I have a lot of similar feelings about homeowners and the decisions that they are making, because like every homeowner has a limited budget, and we are asking them to think about these bigger projects, and spend more money potentially to solve them. Like there's a lot more to the homeowners than just heat pumps are a no-brainer, you should go and install.
Right.
I think we just need to think about all this based on the reality that homeowners and contractors and everyone is facing when they're making any sort of.
Yeah, but the word holistic kind of comes up to me too, because there's been times as a contractor that I remember where nobody could solve this problem they were having. Everybody wanted to go in and add a system, and it was a really bad duct design system that the builder had actually had an engineer design. And what people were doing is they were just installing what was engineered, not looking at it and realizing it wasn't going to work very well, right? And so, and some people don't like zoning, but in this particular case, it's really what had to happen. They had to separate these floors. It was a really bad, and they didn't need to do electronic zoning. We just needed to have control of one floor over the other. And the way the ductwork's running, I literally asked them, I said, listen, this is going to sound like the dumbest question you've ever heard in your life. But are you guys handy? I mean, do you guys go to Home Depot on the weekend? And if there's a hole in the wall, would you patch it? Are you those kind of people? They're like, well, yeah. I was like, so if I was to cut this bulkhead out in this basement, if I was just cut this bulkhead and I was to add a second duct beside it, could you like rebox it out? I mean, is that something that you would be willing to do, like a weekend project kind of thing? They're like, if that would make a difference in our heat and air conditioning, yes. And so, so when I look at things holistically, is if there's things they can do the envelope, maybe the homeowner's handy, and maybe if you point them in the right direction, maybe there's some things they would be willing to do in that project that would then make the whole system be able to get to the end result that we're all looking for, if that makes any sense.
Yeah,
right?
it's just not emergency replacement.
Yeah, exactly. So, Drew, I appreciate your time. I will say this. I'm going to hit the stop button on the. Hey, folks, I hope you enjoyed that interview as much as I did, and look forward to Drew being a guest again soon. And hopefully you look forward to some of our other guests that we have scheduled that we will be announcing soon. So again, if you enjoy what we're doing, like or subscribe. This whole YouTube world is still kind of new to me, and just feel like there's a lot that we can do together. With all of our years' experience, we're worth more together than we are as individuals added up, right? That's what synergy is. 2 and 2 is plus 4 normally, but when you look at synergy, 2 and 2 could be more than that, right? If you take your year's experience and my year's experience and combine them together, and we come together now, we have a lot more years between us, and we can actually help one another. So hopefully you enjoy the conversations that we're having with these folks, and that you're learning something. And if you ever want to come on and talk about HVAC or things about management, or even your personal life and your journey into HVAC, I've also shared about how faith has shaped my HVAC career. You want to talk about that? We're certainly willing to do that too. So we'll dive into all those things. So again, hope to see you soon, and maybe see you along the way. Take care. Be safe.